Hi, we're Team Local Minima, and we've been working on the simultaneous translation and paraphrasing for language education challenge. Machine translation systems typically produce a single output, but in certain cases, it is desirable to have many possible translations of a given input text. This is very common with language learning platforms like Duolingo. Given an input prompt, we want our model to produce a list of acceptable translations. A key point to notice is that not all translations are equally likely. How we take this into account is by using a weighted evaluation metric. We use a weighted F1 where the precision is unweighted and the recall is weighted.
We split our experiments into machine translation and paraphrase sides. On the machine translation side, we used a transformer-based architecture similar to the Attention is All You Need paper. For decoding lists of candidates, we outputted the entire beam width rather than pruning down to just the single best candidate. In our first experiment, we took a large pre-trained model trained on the JParacrawl corpus and fine-tuned that model first on a subtitles corpus and then on the small Duolingo corpus. Our Duolingo training set was all English to Japanese pairs in the corpus, and we found the best results with this two-step fine-tuning method. Our next experiment included trying to get higher coverage in the translations by using diverse beam search. So the way diverse beam search works is it splits the beam into several groups, and each of the subsequent groups are penalized by similarity to the groups that come before it. Our results with diverse beam search indicate that using a very, very small diversity penalty and 3 groups resulted in marginal improvement over regular beam search. One key insight was that encouraging too much diversity can introduce slight semantic shifts, which are deemed incorrect by the dataset. So in this example, the first character in each Japanese sentence indicates that the speaker or the subject must be male, even though the sentences would correctly back translate to "my parents have money." In our initial experiments, we trained our model on all English-Japanese language pairs, no matter what the ground truth weight was. For our third experiment, we instead sample these pairs during training according to the ground truth weights, which means that we're training on the higher weighted examples more often than the lower weight examples. And we found that this gave us a considerable boost in performance.
So to further improve the coverage of the translation results, we tried to add paraphrasing models. We implemented 2 optimization techniques besides the basic LSTM encoder-decoder framework. First is the pairwise discriminator component that outputs a sentence embedding for the whole generated sentence based on both the global and local loss. We also implemented the submodular optimization-based method in the decoding phase by measuring both fidelity and diversity. We trained 2 paraphrasing models on English and Japanese, respectively. Our English paraphrasing model is trained and tested on the PPDB database, and the Japanese paraphrasing model is trained on the Duolingo English-Japanese dataset. As shown in this table, both optimization techniques lead to improvement in terms of blue score in application tests. The combined method achieves the best results. Next, we combine our translation model with the paraphrasing model. There are 2 ways: translation after paraphrasing and paraphrasing after translation. In the experiments, adding more paraphrasing prompts or selecting more translation results from the paraphrased prompts increased the weighted recall, but decreased the weighted F1 score. That means that paraphrasing than translation approach achieves higher coverage and diversity in sacrifice of accuracy. We got similar results for the translation after paraphrasing approach. In comparison, we find that paraphrasing after translation is better than the current approach.
In conclusion, we discovered that high coverage translation is not the same as paraphrasing translations, as slight semantic shifts matter. A little bit of diversity helps the coverage, but too much will hurt performance. And lastly, if weighted graph truth translations are available, you should use these weights during training for best performance.